6.3.1b. Which of the following is true for the function f of x equals x cubed over 3 plus 5x squared over 4 minus 5x over 2 plus 1? And then it gives us three statements. A says it's concave up over the interval between -6 and -5/4. B says it's concave up over the interval between -5/4 and 1/4. And C says it's concave up over the interval between 1/4 and 6. So we're trying to find our point of inflection, if we have one, and then determine around it whether the function is concave up or concave down. And then we'll compare these intervals to what we find. Okay, so concavity comes from the second derivative, f double prime. And in order to find f double prime, I have to first find f prime. And this one's going to use a power rule. So I want to do the power rule on the x cubed, and then divided by 3 is just like multiplying by 1/3. So that's a constant. Your constant multiple rule says you just bring the constant down as part of your answer. So I have x cubed, so that's going to turn into 3x squared, and then divided by 3. Okay, and then the same kind of thing we can do with the 5x squared over 4. I can say 2 times 5 is 10. X to the first, and then divided by 4. And then minus, and remember, if you have m times x, the derivative of that is just the m. So that's going to be 5 over 2. And then, of course, the derivative of a constant is 0. Okay, so being a good math student, I'm going to simplify this. That's just going to be x squared plus 5x over 2 minus 5 over 2. Okay, now I need to do the next derivative, the derivative of the derivative. Okay, the derivative of x squared is 2x. The derivative of 5x over 2 is 5 over 2. And the derivative of negative 5 over 2 is going to be 0, right? Because that's a constant. Okay, so next, to find our possible points of inflection, we set this equal to 0. So we want to say that 2x plus 5 halves is equal to 0. Okay, so that means then that 2x would equal negative 5 halves. Okay, and then divide by 2, right? So I'll get that x is equal to negative 5/4. Okay, that's the location of our only possible point of inflection. All right, so to test the concavity around it, I want to pick test points. Okay, so I usually slap that number onto a number line. So I put my negative 5/4 onto a number line. And then I wanted to do test points around it. So to the left of it, because negative 5/4 is about negative 1.25, or it's exactly negative 1.25, I picked negative 2 on the left of it, and I picked 0 on the right of it. You can pick any value on the left and any value on the right. You can pick something huge like 1,000,000 if you want to on the right, and negative 1,000,000 on the left. Okay, the point is just you pick some representative of that interval and test it. Okay, and I'm just plugging it into that second derivative. And the second derivative was up here. Right, that's my second derivative. So I'm going to plug in negative 2. I'm going to go 2 times negative 2 plus 5 over 2. And I just need to know whether this answer is positive or negative. So that is negative 4 plus 5 halves is just 2.5, right? So that is a negative answer. And I don't care what the value is, I just want to say that it's negative. So on the left, I've got that it's negative, which means concave down. I'm going to abbreviate concave down as CCD, concave down. And I just put a little minus to mean negative. Okay, so I don't care what the number is here other than the fact that it's negative. The sign of it is negative. Okay, same kind of thing but with 0. I want to go 2 times 0 plus 5 halves. Okay, and that's just going to give me 5 halves. And that is positive, right? So I don't really care that it's exactly 5 halves. I just care that it's positive. And so over on the right side of negative 5/4, this means it has a positive second derivative, which means it's concave up. And I abbreviate that as CCU. You can actually write out concave up if you want to. You can just put up, you can just put U or CU, totally your choice. But you just need something so that you can easily check the statements above. Alright, so I got that on the left side of negative 5/4, it's concave down. On the right side, it's concave up. Now let's look at our statements. Statement A says it's concave up between negative 6 and negative 5/4. What did we get? We got between negative 6, which is down here somewhere, and negative 5/4, we got concave down. So according to our information anyway, statement A is false. So false. Okay, and then I want to do statement B next. Concave up between negative 5/4 and 1/4. Negative 5/4 and 1/4, they said up. Alright, here's negative 5/4. 1/4 would be over here on the right of negative 5/4. We got concave up, so yes, that is true. Alright, next between 1/4 and 6. Alright, 1/4 is over to the right of negative 5/4 somewhere, and 6 is even further to the right. That whole section we got concave up. So statement C is also true. Alright, and so then you would choose the choice that says statement A is false and B and C are true.